Welcome back to Overtime Arcade. I'm Charlie, and this is part 6 of the Joust restoration series. I know it's been a while, I'm sorry, we're back at it, and in this episode we're going to head back out to the garage and work on some of the power issues that we're having with this Joust. So we're going to wrap up what we're doing with the transformer assembly. We're going to work on the power supply PCB, start working on that. And yeah, I know this isn't going to be it's probably not the most exciting episode in this series, but it's absolutely necessary to make sure we're getting the correct voltages produced and sent to the other game boards and to the rest of the machine, because if the power's not working, ain't nothing working. So why don't we head out to the garage and get started on all that and start making some progress on this project. Let's go!
Overtime!
Okay, we're out here in the garage, and boy is it cold. It's, I don't know, in the 20s right now. I think it's supposed to get down to 11 degrees overnight. I tried to get out here earlier in the day and do some work, but it was just too cold in the garage, so I actually went out and grabbed a space heater, just a cheap electric thing, and it's helping. It's raised the garage at least a good 5 degrees, and I've got it pointed right at me, so keeping me nice and toasty. Wanted to get back to the Joust and do some power work and start really making progress. I did finally get the reproduction harness in, so I'm excited about helping us make progress. One thing that the harness doesn't have is, you can see on my transformer assembly here, a bunch of wires have been cut. These are the wires that actually go to the power supply board, one of the 5 different PCBs that make up the PCB set for Joust and other Williams games of this era like Robotron. These have been cut off of this transformer, so we need to add those. I could have just sort of done it myself, gotten some wire and the connectors that I need. And this doesn't come on the reproduction harness. So I actually got one made by Charles Klein on the Claw forums. Collector in Colorado, pretty well known. I think he's pretty active on Facebook too, I believe. But yeah, thank you, Charles, for making this sort of set for me that will reconnect back to the transformer and then plug into the power supply board on my Joust. Now there's actually something kind of special here. Charles didn't just sort of copy one for one the original. He upgraded it a little bit. It's the same number of connectors that plug into the whatever this is, 15 or so connections. Let me count this: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, I was right. 15 spot connection on the board. And he actually doubles up a few of these wires. I believe it's this set of 3 over here. So 2 more grounds and 2 more power lines. And there are spots, there's headers on the board for that, but the original Joust, this part of, I guess, the wiring harness only had like a single black, a single green, a single gray and green. And by doubling it up, hopefully we can reduce some of the resistance and prevent things down the road like those headers getting burnt up, which happens all the time on those power PCBs. That happened to my Robotron before it came to me. So what I want to do is solder these wires back onto the transformer assembly. What's nice is that Charles uses the original colors, so I can follow the schematic with color-coded wires telling me, what goes to what, and so that's great. And we'll just have to double up some of these so that we'll put 2 wires on the same lug instead of 1 like there was originally. So thank you, Charles, for that. One thing that I don't know if we'll be able to do in this video, I was hoping to do tonight, is install the rebuild kit on a power supply board that I do have, and then plug this all in together and test our voltages. But I thought I had bought, let me see if we can see what's going on here. So this is a power supply board. This is a Williams D8784. This is the power supply board that would have come in a Joust. or a Robotron, etc. And it comes on this metal sheet along with a heat sink with a couple of transistors, and the soundboard actually goes to the top. And this did originally come from a Joust. It even has this label that says, if you can see that, Joust boards. And I bought this untested, unworking, from a seller that I trust though, and I can even see that there's a capacitor missing here on the power supply board. There's a fuse missing on the soundboard. I see some other things that we're going to have to do. But yeah, and what I wanted to do was rebuild this power supply PCB, install new headers, replace the caps, redo this IDC connector here with a trifurcon plug. But I thought I had ordered one of those rebuild kits, but I guess I was wrong, so I'm going to have to do that. And today is Saturday night, so that won't get shipped until Monday. So we'll see if we get that in time in order to include it in the video. We'll do it eventually, but certainly I'm not going to be doing it tonight. But we'll install Charles's new wiring onto the transformer, and yeah, maybe we'll see if we can install. We've got to replace the marquee light. Anyway, I'm rambling. So what I want to do here, I'll do maybe a couple of these on camera and then the rest myself. So, I kind of want the connector to sort of go like this, right? Okay. So we've got to make these connections. I've got my, what are these? Gray and green. These are carrying the 11.3 volts AC along with the black, and then the green as the ground. And these should go, and I can even see this on the schematic, these should go to lug 15 on the transformer, which is right down here. So we'll need to remove the sort of remnant, if you want to call it that, of the original wire. So I'm just going to throw a little bit of flux on. I'm going to throw some new solder onto that, just to make it easier for the old stuff to come off. Throw a ton on here. All right. And I should be able to come in with my desoldering tool and get this solder off. Just grab my needle nose pliers and kind of pull this off while I'm removing the solder. Sometimes you got to do this a couple times, and I'm melting the wire insulation. Sometimes you got to go a couple times with fresh solder to really get these suckers off. So here's a bit more. Caught my thumb. Oof. It's not so bad though. All right. Let's see what we can do now. Ooh, 800 degrees. I don't think I really burnt myself though. There's the old insulation. We'll grab this wire. It's twisted on there real securely, to prevent it from coming off. All right, that's it for the most part. Just clean that up a little bit. All right, got a nice clean lug there, and that's number 15. It's marked right there. It's marked on the schematic. And that's where both of our gray and green wires are going to go. And we've got a little bit of that original insulation that we can kind of look at just to make sure we've got a good wires in the right spot. And I actually have to install 2 wires there instead of just one, again, because Charles has doubled up. I think he calls it the double wire mod or upgrade, something like that. So we'll come in here with my handy dandy automatic wire strippers. We'll strip off a good healthy amount on both of these. That's one. And we'll do the other. Okay. And I think I kind of want to twist these together. And I think the way it's been going on, the others look like they, let's see, come like this, and then wrap around like that. So like this. Not that it really matters that I do it exactly the same way, but if that worked for Williams originally, it should work for us now. Let me slide over a little bit. Yeah, I'm just like in a stress position, leaning over. Yeah, that's what I want. It goes like this. Wraps around underneath like that. Okay. I think I finally got it, the wire wrapped around the way I want it to. I think some of these lugs go in different directions, and I was just looking at whatever. But I'm just going to come in here and solder this on nice and securely. Don't be afraid to use quite a bit. We want to make sure we have a nice connection here. All right. All right, that looks pretty good. But like I always say, never trust your eyes, trust your multimeter. Put it on continuity beep. In here. Coming like that. You see where I'm testing? All right. So let's do, let me do one more. So actually, let me cross that off the list. 15 is good. Where is it? 15 is good. Right next to it is 14. And 14 is just a single one, single wire. So let's come in here, toss some flux on. This one should go much easier. Put some new solder on. All right. Remove that the old and new solder. There we go. That's falling right off. All right. All right. Just make sure that's fully clean. Okie doke. Strip our new orange wire from Charles's. I don't know if you would call this a harness or part of a harness. A little bit more. There we go. I think Charles called it a kit. And he can sell it to you if you need one. You can go on Clav. I'll put a link to his sale thread. And he can either sell you a kit where he just sells you the wire and the connectors, and you can, or the connector, and you can crimp on pins. He'll sell you the pins, but he'll also sell it to you like this, kind of already assembled for a few dollars more. And Charles has been making harnesses for a couple of years now. It's the first one I've gotten from him. I got the actual full wiring harness from Ken Falta at Golden Age Arcade Parts. But both are good sellers. There we go. That's nice. That's looking real good. I think Ken's got more of a larger scale operation. Although Charles is getting bigger, he recently, I guess, pressed his wife into into service making harnesses. I guess she volunteered. She had seen Charles do it, and so now it's a family business, which I'm always very happy to support things like that. And I think Ken and his wife, I think Golden Age Arcade Parts is a family business too. All right, we'll test that one again with our multimeter. And this time we want the orange connector. And there's on these types of connectors, there's like almost windows for the pins. So rather than trying to cram in your probe into the top of the connector, which you might damage it, bend a pin, or when this is plugged into the header, there's no way to come in from that way. But there's this little window where you can stick your probe in, and then make sure you've got a good connection. And it seems we do. All right. Alrighty. So I'm going to go and do the rest of these on my own. No need to subject you to that sort of struggling. And then when we're done, we'll have our connector ready to go. So let me go ahead and do that. All right, that went on pretty well and pretty uneventfully. Once I got the hang of wrapping the wire around, went on just fine. And I double and triple checked that I got the right wires on the right transformer lugs, and I tested everything with the multimeter on continuity beep just to make sure all our connections are good. So I think we are good to go here. The next thing I want to do is something that I've talked about before but never actually shown on the channel, and that's replace these old header pins and IDC connectors with some trifurcon stuff. So basically the original pins that Williams used, the original header pins, were round, and the connectors themselves have sort of flat blades inside, and you have essentially a round pin making contact with a flat surface, maybe even two sides pinching it together. And it really wasn't a great connection, right? Imagine a ball hitting a flat surface. So you end up often building resistance. The connection gets corroded, builds up resistance, and can burn things up. And something that you often see on these, and this is a Williams D8784 power supply PCB, you often see these connectors in particular, these headers in particular, all burnt up. And often what an op would do in the field to fix it is just solder the wires directly to the back side, the solder side of the PCB. That's what I found in my Robotron that I did years ago. This one really isn't so bad, but in order to avoid that sort of thing, we replaced these header pins with trifurcon, which I believe are square. Yeah, they're square pins. And then the pins themselves are square, pins. And then the female pins are sort of a triangular, they connect on three sides, so you get a better connection from that. So this is really the power supply unit that comes in this generation of Williams games. You have a power supply PCB that takes the power from the transformer assembly, comes in here, and it makes the 3 voltages that are necessary for the board: 5 volts, 12 volts, and I forget what the third one is. And it also has this heat sink with a couple of transistors on it to dissipate the heat rather than having them directly on the board. What I want to do eventually is probably rebuild this board entirely, replace the caps and I think this is BR1, the big bridge rectifier, right? Yeah, that's BR1, isn't it? Well, yeah, BR1. And potentially other parts too, you know, but we'll test those as needed. But for now, at a minimum, what I want to do is replace these two connections, these header pins that the transformer assembly connects to, that I've got, you know, Charles Klein's new wiring for. And I also want to replace the headers and the connector between the power supply PCB and the heatsink. So these things are, especially the heatsink is often missing for whatever reason. So we can just remove this old connector here, pop that right off. And this is called an IDC, which stands for Insulation Displacement Connector. And if you can kind of see this, maybe I can bring it up real close. You see the wires are kind of passing through the top, and they look like they've been cut on the side. And essentially each of these spots, each of these connections has sets of teeth that can bite through and pierce the insulation of the wire and make contact with the actual wire on the inside. And then that goes through to the pin, which goes, the female pin, which connects to the male header pin. And that was a really, really, really easy and fast way to make these connections. You basically line up your wires along the top, you push them through, and then you cut them off on this side, and there you've got your connection. But these aren't particularly good. These are notorious for going bad as well, so we'll replace that too. But first things first, I'm going to replace the headers on this board. I'll show you maybe the small one, and then we can, I'll do the other one off camera. So we've got a 7-pin connection here, and let me see if there's going to be a good way to do this where you get a good angle on the camera and I'm not really, oh man, that is loose. What in the heck? Oh my gosh, look at that. We've got a super, just absolutely, I don't know if you're going to be able to see this. Let me see if I can zoom in here at all on this. Can you see what I'm talking about here? That camera doesn't really want to, oh, here we go. So do you see right here? This is a totally cold joint, cold solder joint. You can see the legs of this capacitor just bouncing around right there. So why don't we actually remove that capacitor right now. We'll do our work to the header and then we'll reinstall it back in. So I'm going to add a tiny little flux. We'll add a tiny bit more solder. Are we looking at the right spot right here? Look at that. We've got it super zoomed in. I guess that's kind of neat, right? Okay. So let's, I don't know if I can really see what I'm doing. Let's come in and add just a touch of fresh solder. To both of these legs. Okay. Then I'll come in with my desoldering tool. Solder that I added may have actually made a better connection. There we go. I think we're free. If you can even see what I'm doing here. Come on, come out. There we go. All right. All right. The positive side is marked, so that's good. So we'll put that off to the side. That's C14. And now we can come in here and have an easier time working on. Let's move the camera down a little bit. All right, now I think I got it. I was fighting the gimbal again to get it to zoom where I want. So we're going to add a little bit of flux to these 7 header positions. All right, I went ahead and swapped in my larger gauge nozzle on the desoldering gun. And we're just adding a bit of flux like I already did, and now we're adding solder, fresh solder, to each of these 7 headers, just to make things a little bit easier, make the old solder flow a little bit better. That's the point of using adding the new solder. Just makes it easier to take the old stuff off. All right. Yeah, one of the things I like about this Hakko desoldering tool is that you can very easily and quickly swap out the tips. So this is if you can see this is a larger gauge tip than I usually use. And this is better for coming in, if you can see what I'm doing, and coming in on these larger header pins. Just taking all that solder off super fast. Hopefully you can see this, and the lighting is good. Unlike other folks, I don't have any kind of degree in filmmaking or whatever, so this is totally amateur hour when it comes to what I'm doing here. Let's see, we're in what kind of shape we're in. Grab my needle nose pliers and see if we can pop this sucker off. Sometimes what you can do is, if they're being really stubborn, you can kind of pull these things one at a time. But I actually try to desolder them as long as I'm not putting too much heat on the board to the point where I potentially am damaging traces or pads. There we go. There we go. I think we're in good shape now. Let's pop this off. There we go. Look at that. Nice clean vias. The pads have not been destroyed. Traces are intact. There we go. And that was the header pins for connection 4J4. And here's our old header. So we're going to want to remember that this is keyed a certain way. So one of these pins has been cut. So we will do the same on our replacement headers. And let me zoom back out. All right. Hopefully you can see what I'm doing. And so these are the replacement headers here. And get these from Peter at arcadepartsandrepair.com. And again, if you can see it, these look like squares. So rather than round pins, and I'll show you the original, rather than round pins, we've got square pins. So there's more surface area to make contact with. So zoom back out. All right, so we're going to swap these in like so. What's nice about these is they come in lengths of like 24, I believe, and you can cut them down to just the size that you want. And so this is a 7-pin connector. So we'll cut 7 off. 1, 2, 3, 4, 5, 6, 7. Double check. 1, 2, 3, 4, 5, 6, 7. So we can come in and just kind of cut in between, and it pops right off. So here's our new 7-pin header, and we can pop it in just like that. Let's see. Pop it in like that. Does not look nice. And then we can come in right here and solder that into place. So here we go. And one thing I like to do is quickly tack maybe the middle pin in place, just so that we have good stability holding the whole row in there. All right. Okay. There's something really therapeutic about this type of work. It gets to be a bit repetitive and monotonous. There's almost a Zen state right there. So let's take a look. I think number 2 and 5 could use just a touch more solder. All right. 5. Okay. Let's take another look at that. All right. Maybe a tiny bit more on 3. And of course, we don't trust our eyes with this. We'll test the connection, but yeah, it should look good too. Okay. How are we doing there on camera? All right. That looks pretty good. We're nice and flush to the board right there. One of the things we need to do though is make sure that we come over. Oops. One of the things we need to do though is make sure that we're keyed the right way. And so if you see on the original, that 3rd pin has been removed. So we'll need to do the same on this one. So we'll just come in with our flush cutters and remove that pin right there. So there's that. We can discard that. And so now we've got a header connection that looks just like the original. Eventually I'm going to do this for every single header on the entire board, replacing them with these square pins designed for trifurcon connectors. I'm still waiting on some of those parts to come in. I've got some that I can do for now, but I'm not going to be able to do the entire PCB set, which I believe is somewhere on the order of 100 header pins. So I'm waiting on those parts to come in. They just shipped today from Peter at arcadepartsandrepair.com. They've got to come from Montana, where he is at, to Virginia, where I'm at. But I've got some left over from a previous project, just not enough to do the entire board. So I'll go ahead and do this one off camera, but I'll do that in a second. What I want to show now, though, is replacing the IDC connector on the heatsink. So we've got this connection right here, and we just move the camera slightly. And so we need to replace this connector with this new Molex 0.156 7-pin connector here. Again, I had this left over from a previous project. I tried to actually buy multiple ones of common parts so that I have them on hand when I need them. Peter's usually good about shipping, but still I tend to get impatient. And so this is going to line up right like this. All right, this is how we're going to replace it. And to make sure we do it the right way, we're going to go through one by one. We'll cut the wire, we'll strip it back, we'll crimp a new pin onto it, and we'll insert it into the corresponding slot in the new connector. So let me grab my strippers, or my wire strippers, and my crimp tool. And again, I have female crimp pins left over from a previous project. I've got these right here, Molex 0.156 female pins. And so the first one we'll do is this reddish orange wire. I'm going to come in here and cut this as close as I can as possible to the connector so that I've got as much slack as possible to work with here. We will come in and strip just a little bit of this off. Let me see if I can zoom in to really show you what I'm doing here. Come in here and strip just a little bit of this off. That should be plenty. Twist it a little bit. All right. And then we will grab a pin. Okay. And see how See the sort of shape of this and how it grabs onto the square pin from both sides and the bottom, so it really does make 3 connections, and it's got this sort of flexed over part to really provide some tension there. So let's see if we can do this really nicely on camera. Here's my ratchet and crimp tool. I'm going to take my pin, which has 2 sets of teeth here. So the back part here, this is going to bite into the sheathing, into the insulation, and these teeth right here are going to grab onto the bare wire itself. So we line it up like so. All right, so that's in there, ready to go. And I kind of want to make sure I'm doing this right, just because I don't have a ton of slack to work with here. Just make sure I got this lined up right. All right, so we're right in there, and we can slide our wire in, and we want it to see come through. This is a little bit long, actually. Cut too much of the insulation off. So let's twist it down nice and hard. Cut a bit of this excess off. That should be plenty. All right, and so let's, hopefully showing this, we can insert the wire in. Man, I don't like how this is coming through, or not coming through. All right, grabbed a new pin just because I have extra of those and I don't have extra wire to make mistakes. So again, we're lining it up. We're making sure that it goes through. I'm just getting nervous here. Yeah, it's not the end of the world if I make a mistake. I can always redo this, but I'm trying to get it right. All right, here we go. All right, I think we've got a good crimp. Of course, we'll test it, but that looks pretty good to me. Let's see, we can test that right now, actually. Grabbing my multimeter. We're going to set this on continuity beep. All right. The orange or reddish wire kind of connects here, and we've got a good connection. All right, I'm happy with that. So that's one down. Let me do one more. Oh, and all right, so let's insert it into the new connector. So again, I'm going to line this up exactly how it is with the old one. And so that orange wire is going to go into this first slot here. And we will position it to go just like so. Slide it in until you hear a click. Am I the right way? No, maybe I'm backwards. Oh, no. Here we go. I thought maybe I had it in backwards, but I actually had it exactly right. And you have this little window here that you can test. You can put your probe in from your multimeter to check for continuity and make other tests without sort of even removing the connector or the connection housing from the headers. So that's good. So we got one down and 5 more to go, because even though this is a 7-pin connection, we've only got 6 of them populated. So this next wire is kind of blue, and again, we'll strip it back. We really don't need to take much off. So let's see. plenty. Yeah, 1/8 of an inch should be enough. Give that a decent enough twist just to help keep those strands together. All right. Okay. Grab another female pin. Put it in our crimper like this. All right. And this crimper has sort of like 2 levels, right? One to crimp the insulation side, and you can kind of see they're a little bit offset in there, which is how they're supposed to be. So one to crimp the insulation side, and one sort of level to crimp the wires. All right. I don't really like that one. I don't think I got enough of the insulation, so no problem. We'll cut it off. I don't want to do this a lot because I don't have a ton of wiring here to work with. I can always replace the wiring, but you know, that's an extra step that I don't want to do. All right. Twist it a bit. Sorry if I bumped the camera. Grab another pin. You're seeing it. This is real life. This is every step. Load that up into the crimper. All right. And then come in here. I feel like it's getting hung up in there. Let's see what's going on with this. All right, I use my needle nose pliers just to bowl out, widen out the pin just a tiny bit to make it easier to get the insulation to its right spot. There we go. That feels much better. I can see it on the other side. There we go. Yeah, that's a good crimp. That is a good crimp. Again, we'll double check it. Okay. Continuity beep. We'll find our blue wire. Connection is right there. And we're good. So I'm happy with that. So let's line everything up again. So we're like this. That wire was in position 2. So we'll twist that around and slide it in until it clicks. There we go. That looks good to me. So the next one is actually empty. But actually, on the original, it's filled, right? It's filled in. And not to worry, I do have plugs for exactly this purpose, right? Makes it so that there's no way we can plug the header into the wrong, or plug the connector into the wrong header. So we just come in here and push this in all the way, and it pops, and we cut off the little top of it with our flush cutter. And now we've got it keyed so that this can't go, if you can see that, this can't go into onto the wrong header, because the header pin, if it's in the wrong spot and has a pin here, it can't go in. There's no way for it to go in. So I'm going to do these last 4 wires off camera. Like I said, I'll do the other, the larger header pins header pin connection on the power PCB, and then we'll come back, hook it up, and test it out. All right, so what have we done, and where are we at this point? Well, I went ahead and replaced the other set of header pins on this side, which goes to the transformer assembly via the replacement wiring that I got from Charles Klein. I finished replacing the connector housing for the transistor heatsink. So we're plugged in here. And I think at this point, we're ready to test this thing. So I printed out the schematic for the D8784 Williams power supply PCB, and I confirmed that the 3 LEDs down here are for plus 5 volts DC, plus 12 volts DC, and negative 5 volts DC. It gives you these 3 LED indicator lights, you know, just to kind of tell you if the expected voltages are being produced. We've also got a number of test points in various spots on this PCB where we can, you know, check the exact voltages that are being produced. I used a alligator clip wire to connect ground from the transformer assembly on the sort of fragment of the grounding strap to this metal plate. This is the metal plate that came inside the cabinet. I pulled it out of the Joust cabinet, mounted the power supply PCB and the transistor heatsink to it. One thing I had to do was get some new screws. So the PCB gets mounted via or with a machine screw that looks like this, and there weren't enough of them. So I went to Ace Hardware and I found the right matching size, which are these machine screws, you know, size 8, sort of 8, I guess, is like the gauge or the thickness of the screw. 32 is the, I believe, the threading size, and they're 1/2 inch long. So I got a whole bunch of these and marked them with what I'm using them for, so I've got easy access to them in the future, because I'll be doing more of these in the future. The other thing that these screws have is, if you can see it, these are toothed lock washers, so I had to buy a bunch of corresponding ones for that. So that 1/2 inch size is what's used to mount the PCBs to this metal plate, and the same thing goes for the soundboard goes here, and there's another metal plate that goes on the inside of the lower back door that the MPU widget board and ROM board are mounted the same way. The transistor heatsink, however, uses little 1/4 inch versions of these, which I couldn't find at Ace Hardware, so I had to bust up my Dremel and cut these down to size. So that being said, I think we're ready to test this, right? So I've got it all plugged in. Charles Klein's new transformer wiring going into, this is connector 4JI with the new header pins there. I've got the transistor heatsink mounted with a new connector housing to the new header pins for 4J4, or I guess that was 4J1, this is 4J4. We're mounted on the board, ground to the transformer. I'm actually still using the old AC portion of the wiring harness. Just if you remember, I use these wire nuts to sort of simulate the power switch being on, the main power switch being on, and the, what do you call them? The interlock switches being closed as well. Because the new one has, you know, bare wire ready to be soldered to those switches, so we'll use this for now. Got the power cord plugged into my strip here, and I'm ready to turn the thing on. The first thing that we're going to look for is these 3 LED lights, and hopefully all 3 of these are illuminated. That's our sort of first indication that we've got good power being produced here. I did test the voltage, or I tested the fuses already. These are the fuses that came with this power supply PCB, and they all seemed okay. Like I said, no matter what, we are going to still use the rebuild kit. We're going to replace at a minimum the caps. We'll put in new fuses. We'll replace BR1. We'll redo the other headers and anything else that needs to be done. But let's cross our fingers and see if we get those LEDs lit up. 3, 2, 1. Okay, little sigh of relief there. All 3 of these LEDs are lit up, if you can see that. So that tells us that at least the PCB thinks it's producing the correct voltages for +5, +12, and -5. So that's great. But let's go and actually test the voltages, measure the voltages, and see exactly what we're getting. So we can put our multimeter there on DC volts. I think you can see that. I already went ahead and connected the black lead, the common lead, to test point 2, which on the schematic it tells us that test point 2 right here is ground. It's sort of tucked in there. These test points aren't necessarily all in the most convenient spots. Some of them are like actual lugs on the board, like points, right? Like almost like header pins that you connect to. Some of them it says like test point 1 is actually this lead coming off of this resistor. So we'll carefully come in here, and for test point 1, we're looking for that plus 5 volts DC regulated. So I can come in here carefully and see what we get. 5.024. That's really good. Write that down, 5.024 volts DC. So it's just over 5 volts. You don't want it to be much higher than that. 5.1 at the power supply is kind of okay. There'll be a little bit of droppage because of the load, because of the all the wires that it has to go through. So maybe that could be a little bit higher, but that's actually pretty good, especially since we really haven't rebuilt this power supply PCB yet. All right, that was test point 1, so that one is good. Test point 2 is ground. Test point 3 is the plus 12 volts DC regulated, and that is on this side of this resistor. All right, 12.15, that's pretty good. So that checks out. Let's see, test point 4 is over here, and it's the -5, and that's tucked in right over here. -4.96, let's call it. -4.96, that's not bad. Let's see, test point 5 is right here in the middle. That's plus 12 volts unregulated, so that won't be necessarily be right on the spot. I did go ahead and re-solder in that C14 that we had pulled out because it had a cold solder joint and was kind of in the way. So at test point 5, we get 13.77, and that's okay because that's an unregulated voltage. 13.77, that looks good. And down below test point 6, we should get -12 volts unregulated. Oh, what's funny? Is that a screening error on this board? So this says, even though it's like, it's screen printed as test point 5, which is the same as up here. Let me actually see if I can show that to you in a way without bridging anything. So take a look at this. Hello. Coming down here. You can kind of see it already what I'm talking about. So test point 5 is right here, and that's clearly marked as test point 5. It's coming real close. Test point 5 right there. And you can see underneath the screen printing, there's sort of like an embossed 5 right there, okay? If you come over here, what does that say? That also says test point 5, but the embossing, where's my finger, does have a 6. So that's kind of funny. I don't know if that's a well-known thing or not. I never knew that before. So let's come back here. And those lights are still on, so hey, this stuff is doing its job as it is right now, so that's pretty good. Let's see, so where were we? Yeah, test point 5 was supposed to be 12 volts DC unregulated. We had 13.77. And test point 6, incorrectly marked with the silk screen, should be -12 unregulated. And we're getting -14.15. Again, that's fine because this is an unregulated voltage. -14, -14.15, right? And double check that. At -14.15. So that one's good. Is there a test point 7? I am not seeing one. There is another spot we can test over here. The sort of third, well, from the left, the third from the left header pin on 4J3 should be 27 volts DC unregulated. So let's carefully come in here. And that's, whoa, That's 34.8. That seems high, even for an unregulated voltage. 34.8. Let's double check that. Trying not to touch anything other than that pin. Yeah, 34.8. So that's probably okay though. Yeah, so like I said, I'm still, let's actually turn this off. Look at that. So I still want to go ahead and rebuild this power supply PCB just for the heck of it. Again, you know, these are the original capacitors. We've even got the stickers and whatever with the Williams serial number and whatever warranty sort of warning. So those are, you know, beyond their intended lifespan. So I do want to replace those. We'll put new fuses in. We'll replace the other header pins. We'll replace the bridge rectifier number 1, which is, you know, sort of known for kind of going bad. And, you know, the rebuild kit that you get from Arcade Parts and Repair has, you know, quite a few other parts in it. It has, I believe, the other 2 bridge rectifiers, 2 and 3. It has these ICs. I think those are voltage regulators. I can't remember. But we'll hold on to those in case we need them. So it's good to have them on hand. And if, you know, if something happens down the road, we're not getting kind of the outputs we expect, you know, we'll deal with that then. But for now, we're not going to use those extra parts. And, you know, I am really tempted right now to grab my other, the rest of the PCB set, wire this all up, throw the new, you know, reproduction wiring harness that I got from Golden Age Arcade Parts, hook up the monitor, and see if we get Joust on the screen. But I don't think I'm actually going to do that tonight. It's getting late. It's past midnight. It's getting cold out here in the garage. Call me a wimp, whatever. So I think we're going to wait on that, especially because, you know, I do want to go through and replace all of the other headers. I'm not going to subject you to that. Don't worry. I want to replace all those headers. I do want to replace the transistors, the bottle cap transistors on this heat sink. There was actually some more cold solder joints that I noticed on the power supply PCB, especially at the other header connections. So when we install the new headers, the new header pins, will take care of that there. I don't want to go do all that work tonight, right? Double check all the cold solder, whatever. There's also something I noticed on the soundboard. I actually have 3 soundboards that I guess I could use, but the one that sort of matches the PCB set that I want to use has there's a 2-position dip switch that's broken. I need to order one. I couldn't find one on Peter's site, so there's a couple other places I think I can get it from. Anyway, I'm rambling. That's all to say that. I think we're going to wrap up this video here. It's probably a bit of a shorter one. I always say that, and it turns out in editing that it's not that short. I'm going to, you know, I've got the parts coming from Peter, hopefully in another maybe 48 hours. They shipped out today. They left Montana today, so hopefully it should get to me pretty soon. So I'll go ahead and wrap up the video here. I'll get this out, and then I'll do another quick video as soon as those parts come in, and hopefully by the end of that video, we will see Joust running on a monitor. So yeah, I think that'll do it here. Again, thanks for, you know, all the awesome feedback. You know, if you haven't subscribed, please do so. It really shows me that you know, like the content that I'm producing and want me to do more. But anyway, thanks for all the views, the likes, the comments, everything. I know there's folks out there sharing this with their friends, you know, other people that they think might enjoy this content. And I do it for you all. So thanks as always for that. So with that, that'll do it for this episode of Overtime Arcade. I'm Charlie, and I'll see you next time.
Overtime!